Good morning, good afternoon, or good evening, whenever you're watching this video. Today is May 11th, 2020. Today your homework for Charles and Boyle's Law was due. On May 15th, your homework for this lecture is due. We're going to cover two new gas laws today, Avogadros Law and combined gas laws. So you notice, still the same meme over here. So remember that 1 atmosphere equals 760 millimeters of mercury. Same thing, just different units, etc. All right. So the first law is Avogadro's law. So this name should sound a little familiar. And so whenever we hear Avogadro, we do not think of avocado, even though it's written in green. Not avocado, but moles. Remember, symbolized by the letter lowercase n. And volume and number of moles are related directly or very directly. That means if one goes up, the other goes up. One goes down, the other goes down. So this is similar to Charles's law, but which dealt with temperature. The demo that you should have seen is the one where I'm blowing a balloon. So remember that each breath that I breathe into the balloon is related to a mole, for example. So if I take one breath, so 1 mole, it has a certain volume. If I take 2 breaths into a balloon, that's 2 moles, and you'll remember from the video that the volume of the gas in the balloon was a little bit bigger. So the number of moles increase, so does the volume of the gas. So first question, 0.15 moles of helium gas has a certain volume, 3.6 liters. If an additional 0.25 moles is added, what will be the new volume? So some of the questions will be worded a little differently. So you have to be able to read and interpret it correctly. If not, then you'll miss the boat completely. So a certain gas has a number of moles, so that's that one, and it has a certain volume. Oops. Volume. So let's mark these both 1 and 1 because they're both related to each other. This volume of gas has this number of moles. If an additional 0.25 is added, so that means my N2 is actually 0.25 plus 0.15. So this one will be, I believe it is, 0.4 moles. 0.0, yes, moles. That is my N2. What is my V2? So we identify what we're given in the problem. We write down our formula. V1 over N1 equals V2 over N2. We are trying to solve for V2, so we're going to cross multiply. And we're trying to solve for V2. So V1, N2 divided by N1, that is my V2. So then we plug in our numbers like before. N2 is 0.40 moles. My N1 is 0.15 moles. This is my V2. So I'm running out of space, obviously. I have to do the actual math somewhere else. Alrighty, so my V2 equals 9.6 liters. And box it in. Second question, 10.3 liters of chlorine gas or 0.42 moles of CO2 leaked from a gas cylinder. 2 hours later, 16 liters had escaped in total. During this time, no change in pressure or temperature. What is the total number of moles of Cl2 that escaped? So we have a V, we have an N, we have another V here, and we're trying to find total number of N right here. So that means it is another Avogadro's law. So these are grouped together like this, 10.3 liters, and the way it's described, that's describing that in the sentence. The other one must be V2N2. Total number of moles of Cl2. Okay, so 0.420 moles V2 is 16 liters, like that, divided by 10.3. Zero 0.652 for blah blah blah. 3 sig fig, so let's put 0.652 and then moles. Cl2. Real life applications of Avogadro's law. So, similar when I was blowing up the balloon, as you blow up a basketball, make it be able to play, use it, etc., whatever, you're forcing more gas molecules into it. So the more molecules, the greater the volume. More molecules, more moles, greater the volume, therefore the basketball inflates. Second example, so you'll see in the GIF, there's like a little bit of air that's shown being inhaled by the person. Therefore, their lungs expand as they fill with air. So if I inhale, I'm inhaling more moles, greater volume. I exhale, I'm releasing more moles, I'm releasing volume, releasing gas. So your increase in moles, when you inhale, that means your volume of your lungs expands. Exhale, you decrease the number of moles in your lungs, therefore your volume decreases.